All right, guys, welcome to this page of the notes, and here's what we're going to do. We're going to talk about a couple of ways of changing around a conditional statement. Remember, a conditional statement is if P, then Q, right? If P, then Q, which I have right here, right? Conditional statement, if P, then Q. What we're going to talk about are a couple of ways of moving those things around and what we call those, what those special names are for those conditional statements, okay? Now, here in this section, we're not really going to, what I'm going to cover, I'm not really going to ask you to do very much of this on like a homework or a quiz, because actually they're going to show up a little bit later. But remember, geometry is a language, all right? And you've got to learn the language of geometry. And the more exposure you get to the language, the better you'll be at it, all right? So really, the idea here is I'm going to go through these next couple of things just to sort of introduce you to them so that you hear them, so that you've seen them, and then when we come back to them later on, it won't be brand new. You'll be like, oh, wait, I remember doing that before. And again, we'll already have some prior knowledge to kind of help you gain a deeper understanding when we see these things again later on. So here we go. You have a conditional statement. If P, then Q, right? If it is raining, then I'll use an umbrella. The first thing we want to talk about is a way of changing that conditional statement, and it's known as a converse statement, right? Here's the way that the converse statement works. Converse is, and we've actually seen this before. We've already talked about converse a couple of times. You're going to interchange, switch the hypothesis and the conclusion, right? So if my conditional statement, if it's raining, then I will use an umbrella. The converse. Switch them, right? So here's what I've got. I have if P, then Q. Converse, switch. It's going to be if Q, then P, right? This is my hypothesis. This is my conclusion. H, C. Hypothesis, conclusion. Converse statement, they switch places. The conclusion will come before the hypothesis. Okay? Right? So, if it is raining, then I will use the umbrella. Converse statement, if I use an umbrella, then it is raining. Switch the hypothesis and the conclusion. Right? Switch it from if P, then Q to if Q, then P. That's it. That's how the converse works, all right? And we've already seen that a couple of times. Now, a whole different discussion is the validity of a converse statement. Okay? Take a look at it. If I use an umbrella, then it is raining. Is that true? No, I have seen plenty. Right now I live in the state of Florida, and I have seen plenty of people walking around with an umbrella when it is not raining just to give themselves some shade from the sun, which during the summer is incredibly intense. In that case, it's not raining, but they're still using an umbrella. So we'll talk more later about whether a converse statement is actually true or not. Just because the conditional statement is true does not mean that the converse has to be true. In fact, a conditional statement could be true and a converse may not be true. But we'll talk about that a little bit more later. For now, just a little bit of practice. So here we go. Write a conditional and converse of each statement. Decide if it's true or false. So here we go. Adjacent angles have a common side, right? So if I have adjacent angles, then they have a common side, okay? The converse would be, if angles have a common side, then they are adjacent angles, right? Switch the hypothesis and the conclusion. An angle that measures 120 degrees is an obtuse angle. If an angle measures 120 degrees, then it is an obtuse angle. That's the conditional. The converse, switch them. If an angle is 120 degrees, then it is an obtuse angle, right? Just switch from if P then Q to if Q then P. Right? That's all you're doing. Two angles with the same measure are congruent. So if two angles have the same measure, then they are congruent. Converse, switch it. If two angles are congruent, then they have the same measure. All right, that's all we're doing. Conditional statement and the converse. All right? let's move on here. We'll try a couple more, right? Again, I'm just introducing you to these things. We will talk about them way more. They'll show up again later on. I just don't want to, kind of introduce you to them here before we get to that. Okay, inverse statement. Again, here's my conditional. If P, then Q, right? Now, here's the way that this works. What you're going to do for an inverse statement is you're going to negate. You will negate both the hypothesis and the conclusion. So here's the way it works. If P, then Q. If it is raining, I will use an umbrella. The inverse would be to negate the hypothesis and the conclusion, simply meaning change them to if it is to if it is not, right? So if it's raining, then I will use an umbrella. The inverse statement, the little squiggle mark means to negate, right? So if not P, then not Q, right? So if it is not raining, then I do not use an umbrella. You just negate both statements, all right? So if it is raining, then I use an umbrella. The inverse, if it is not raining, then I do not use an umbrella, okay? You just negate both of the statements. We can practice this a couple of times. Right down here, if 3 points lie on a line, then they are collinear. So, the inverse statement. If 3 points do not lie on a line, then they are not collinear, right? Take the statements you've been given and negate them, right? Make them negative, right? So, again, if 3 points do not lie on a line, if I say if 3 points lie on a line, negating that would be if 3 points do not lie on a line. They are collinear, negating that would be then they are not collinear, right? That's it, that's your inverse statement. If angles are vertical, then they are congruent. So, to negate that, if angles are not vertical angles, then they are not congruent, right? Just negate both the hypothesis and the conclusion. Really, really easy stuff. I know you guys, I'm beating a dead horse here. Let's move on. Contrapositive. The contrapositive statement, all right, here's what we're going to do. You've been given a conditional, if P, then Q. If P, then Q. For the contrapositive, what you're going to do is you are going to do both the converse and the inverse. So, here's the way it's going to work. You are, if P, then Q. You're going to switch P and Q, right? So Q will come first, then P. Switch the hypothesis and the conclusion. But you will negate both of them, right? So you're going to switch the hypothesis and the conclusion and negate both statements. Here we go. You got this. If it is raining, then I will use an umbrella. Switch the hypothesis and the conclusion and make them negate both statements. So if I do not use an umbrella, then it is not raining. If I do not use an umbrella, then it is not raining, right? Umbrella was the conclusion. Now it's the hypothesis, right? It's switched places. If it is raining was the hypothesis, now it's second. It comes second, and I've negated both statements. That's it. That's the contrapositive. Let's try a couple of these. Oh wait, did I do? Whoa. I am really sorry about that. I didn't give you any other examples. Again, hopefully that makes sense. What we're doing is just for a contrapositive, switch the order, like you do with the converse, and negate both statements like we do with the inverse. All right, so the contrapositive is both taking the converse and the inverse, and we call it the contrapositive. Switch them and negate both statements. All right, and that's a great example of that. All right, what we're going to do on the next page of the notes is we're going to go ahead and start looking at how we're going to write proofs. All right, so head on over to the next page of the notes, and I'll meet you guys there.